Hello, in this video, I'm going to explain how to create a program, which I call a define program, using the C programming language so that it can find the occurrences of a given pattern in a standard input. So the assumption is that the standard input is made of multiple lines, no more than 1,000. And basically, the user enters multiple lines, and at the end, after the input is over, it presses the end of file character, which is like it enters the end of file character, which is Control D in Unix, and then after the end of file, the program searches for the pattern in all the lines, and it prints those lines that have a pattern in them or that contain at least one occurrence of the pattern. That's the default behavior of the program. Now, there are going to be some options in this program, like almost any other program in Unix, that the user can pass when it's running the program in the form of command line arguments, which I'm going to explain them next. So first of all, let's say when you're running a program, a mandatory command line argument must be the pattern that you're trying to find, and the pattern is given to the program as the last command line argument. It's always the last. Okay, we don't change that in any type of execution for this program. We always place the pattern in the end. And other than pattern, there might be one or more command line arguments in the following form. Let's say the program name is find, so you say find. You can use -n, -x, -s, -r, -m, -c, -f, -p, and then the pattern at the end. The pattern can be any word as long as it is not made of white spaces. It's considered to be a single word. Just remember that the order of these options can change. You don't need to have -n first. It can be at the middle. You don't need to have -p last. It can be at the middle. Also, what I can say about the options is that you can combine multiple options into one argument. So instead of having -n and -x separately, you can have -nx or -xn and then remove the other one. So that's totally fine. You can combine all of the flags into one command arguments, say -n, x, s, r, m, c, f, p, all in the same option. I'm sorry, in the same flag. So, or in the same command argument. You don't need to have a dash for every single option. And here are the meaning of every flag or option. -n prints out the line number in the output. When it's going to print the lines, it adds the line number at the beginning. -x prints out the lines that do not have the pattern. So it kind of reverses the functionality of the program. Program by default prints the lines that contain a pattern, but if you do -x, it's going to print the lines that do not have the pattern. So it prints the other lines. All right, and then -s prints out the lines in the alphabetical order. So it doesn't care about the order the lines were received in the standard input. It's not going to be first in, first out anymore. It's going to be in alphabetical order. Whichever line has lower alphabetical order will come first. -r reverses the lines and prints the lines in the reverse order. So in other words, when you do -r, we're going to print the lines in last in, first out order. dash M finds the pattern only if it matches the whole word in the standard input. So that's for matching the whole word. For example, if you're looking for apple in a sentence that contains apples, and there is a dash M flag, it doesn't match apple with apples because there's an S at the end of apples. However, if there is no dash M, the default behavior matches apple with apples, because by default, we don't care about matching the whole word. As long as the pattern can be found partially in a word, no, I should say, as long as the pattern is found in a word, it matches the line containing that word. Dash C ignores the case when finding the pattern string. So if you have dash C and you're looking for the word apple with all lower cases, and inside in a sentence you have capital letter A, apple, we match it. But in default settings, it shouldn't be the case. We should not match a lowercase with an uppercase. So by default, it's case sensitive. Dash C makes it case insensitive. Dash F prints out the index of the first occurrence of pattern found in each line. There should be a certain way of doing this. I'm going to explain that at the end when I'm showing you some examples of input and output for this program. And then dash P partially prints out the input line. It uses ellipsis to shorten lines. As an example, if you're looking for the word apple in this sentence, my favorite dessert is apple pie with coffee, then the output is going to look like this. So we first place the first 10 letters of the input, followed by an ellipsis, followed by the keyword, which is found at the middle of the sentence, and then another ellipsis, and then the last 5 characters of the input line. So this is the end of all the options that we can think of for this program. Now let's get into the details of the code. The code that I'm showing you is not implementing all the flags or all the options, but it provides you with a great platform in which you can continue the implementation until you fully implement this very nice program. This is a very versatile program. It can find patterns in standard input with a lot of options. So it's a great program to use. Let me show you the main method first, or the main function first. In the main function, which I get argc and argv, as you know, argc represents how many arguments we have, including the first argument, which is the name of executable for the program, and argv are basically the list of all the command line arguments. If argc is less than 2, we're gonna raise an error. That's a fatal error. We're gonna end the program. 1 is the error code. Throughout the program, I have raised multiple errors, and each one has its own error code. So this way, we can have an easier time troubleshooting the program or finding out what went wrong when a program crashes. This basically means we must have at least one command line argument for this program, and that would be the pattern. You cannot run this program without any without passing any pattern, because what do you want to find if you don't find any pattern, if you don't pass any pattern? So if it's less than 2, we're gonna raise this error. The error is a function which I have defined here myself. It's a very simple function. It prints out find fatal error, illegal usage, error code, %d, which %d will be replaced by the error code, which is the input parameter. And then it tells the user what the correct usage is. The correct usage is going to be find -n-x-s-r-m-c-f-p, followed by pattern. And then it exits with the system call exit. System call exit asks the operating system to basically terminate this process after returning this error code. And that's going to be the end of the program. So this is a very short way of ending the program, but if the user doesn't forget the pattern in the command line argument, we're going to go forward. We say the pattern is going to be the duplicate of argument v arg c -1. This is basically the very last command line argument, which is considered to be the pattern. Then I have compiled, or I have set all the flags for this program using the set flags function. I pass both argc and argv to the set flags function, and this returns the flags option. What is flags? I'm going to explain that. So I'm going to begin by telling you what flags is, because you may wonder, wait a minute, why don't you have a data type here? It should be either an integer or unsigned or char or I don't know, double float. What is flags? The answer is in the other file that I have created. I have created a find.h, which I have included at the beginning of this find.c, which contains the main function of my program. The find.h contains this, and this is called an enumerator in C. The enumerators exist in multiple languages like C#, C, C++, Java, so on and so forth, but the Java version is not as useful as the C version. The C version of enumerators are extremely useful. I'm going to show you how. I'm going to list a bunch of constants in an enumerator. Basically, an enumerator is a way of defining a list of constants, each one with a certain value in a very organized fashion. Not only that, when you define an enumerator, you're defining a type as well. And you can use the enumerator as a data type for any variable that you define or declare at the at any time and at any location in your program. So I define an enumerator. My enumerator is nameless. I could have added a name to it. I could have called it my enum, but I didn't add a name to it because I have type defined it as flags. Type def is another keyword that you can use in C to give an alternative name to any data type. So I have type defined this enumerator as flags. So in the future, whenever I'm going to refer to this type, I only say flags. But if I didn't have this type def, I could have given a name to it. I would call it my enum, but anytime in the program I want to refer to this enumerator, I should say enum my enum. I should just use two separate words. One is enum, one is my enum to refer to this enumerator. But when I say type def enum, and then I pass the alternative name to the type def, then it's going to be extremely simple. That means if you want to refer to this enumerator, only use a single word identifier, and that would be the flag, right? Which basically a good name because it represents the flags of my program. And this enum is going to, as I said, list a bunch of like constant variables, constant, I should say, unsigned variables. Each of them are unsigned, numbered, except, sorted, reversed, matched, case, first, partial. Numbered is set to 1, except is set to 1 shift to the left 1 time, which means 2. Sorted is set to 1 shifted to the left 2 times, which is equal to 4. Reversed is 8. Matched is 1 shifted to the left 4 times, which is 16. Case is 32. First is 64. Partial is 128. So as you see, these constants are set to powers of 2. Why? Because as you may have noticed in C, we don't have Booleans. So when we want to create a list of Booleans, let's say for creating flags for a program, like creating a bunch of Booleans, a bunch of an array of Booleans to show different binary values, we're gonna use, we cannot have Boolean, we cannot have like an type Boolean in C. Instead, we use a single unsigned integer. An integer can hold up to 32 bits because that's how the length of an integer is defined in most of computer hardwares. And when I say 32 bits or 32 binary numbers, I mean 32 zeros and ones, right? And each bit or each 0 and 1 can potentially represent a Boolean. If the bit is 0, that's a false Boolean. If it's 1, it's a true Boolean. If it's 1, it's true. If it's 0, it's false. So let's index these bits. And I don't care about the rest. There are a total of 32. I'm not going to write down all of them. I only care about the first 8 bits. Because I only have 8 elements. If I had more, then I would care about more of them. But you can have up to 32 different constants in your enumerator. And that's because the length of an unsigned number, an unsigned integer in C is 32 bits. And basically, because numbered is 1, I'm going to refer to this bit as the numbered flag. I'm going to refer to the next bit as except flag. I'm going to refer to the next bit as sorted flag. I'm going to refer to the next one as reversed. Next one is going to be matched. Next one is going to be case. Next one is going to be first. And last one is going to be partial. You may say, why do you do that? Because the weight of each bit, when you're calculating the numerical value of an unsigned integer, the weight of each bit is a power of 2. The weight of the very first bit is 1. The weight of the next bit is 2. The next one is 4. The next one is 8. The next one is 16. And this is exactly how I defined all the constants. What does that mean when I say weight? Imagine all of them are 0, right? Except bit 2 and bit 0, right? These two are 1, the rest are all 0. The weight of 2 is 4, and the weight of bit 0 is 1. When I add these two, my options would be 4 plus 1, which is 5, right? So if the flag is equal to 5, it means that I have the numbered flag raised, and I have the sorted flag raised, right? Because it's basically bit 2 and bit 0. Bit 2 means sorted, bit 0 means numbered. And that's gonna basically tell me, let's run the program with these options, with a sorted option and numbered option. Why? Because the user have used -s and -n when it's running the program, right? So this is an extremely great way to store all the options for a program using an enumerator, and then later I'll show you how to basically set all the flags and then retrieve them by using bitwise operators like bitwise AND or bitwise OR. So far, we have used the bitwise, shift left logical operator, which is extremely useful for creating powers of 2, right, as I showed you before. All right, so let's clear all the drawings. Let's switch back to the find.c. I'm gonna go over the rest of the program. As I said, the flags is going to be an enumerator option that's going to be equal to set flags of this. What is set flags? Set flags is a function I define in the find.c file, and as you see here, I have said let's have an option set to 0. That's a default. That means by default all the flags are down. When I say 0, I mean I have 32 bits of 0. That means the last 8 bits are 0. That means all the flags are down. Then I have traversed my argv array by doing this for loop. The reason I'm not beginning from 0 and I begin from 1 is because index 0 of argv contains the name of the executable, which is going to be ./find. When you run your program by the ./find -n-x, so on and so forth. So we don't care about argv0. We're going to begin at index 1, and I'm not going to go all the way to the argc-1, which is the last index. Why? Because the last index is already parsed and already considered as a pattern, so I don't need that. Anything other than that, from 1 all the way to argc-2 would be the indices that I'm interested in the argv array that help me set all the flags properly. So in this for loop, the first thing I will check is if the argument that I'm parsing doesn't begin with a dash. So if the index 0 of that argument is not dash, then I'm going to raise another error. So this basically means if argument does not start with dash, raise another error with another error code. Let the user know what the correct usage is, and end the program and throw a fatal error message out. And then in this for loop, what I do is basically I go over all the characters of the ith argument. So as you see, this for loop is an inner for loop or the outer for loop, because for every single argument, I may have multiple characters after the dash. So I need to keep going through that argument and see if I can find any of the following characters. The lowercase or capital letter n will raise the numbered flag. When you want to raise the flag, all you need to do is to or equal it. So that or equal means options equal option or numbered. This or is not the or that you use to logically or two conditions in an if statement. This is different. This bitwise or basically ors the bits of option, which is an unsigned 32-bit number, with numbered, which is a constant 32-bit number. And when I say that, I mean it has to do an OR operation. Option is originally 0, and the rightmost bit is 0. When I OR it with numbered, which is equal to 1, and all the bits are 0 except the rightmost bit, will result in an option that is basically made of multiple bits, or 32 bits, but the rightmost bit is always 1 because we have ORed option with numbered. That means we raise the bit representing the numbered flag. And in this case, if it's X, we're gonna OR the option with accept. If the case is S, I'm sorry, if the letter is S, lower or capital letter. We're gonna raise the sorted flag. If it's R, we're gonna raise the reverse flag. If it's M, we're gonna raise the matched flag. If it's C, we're gonna raise the case flag. If it's F, we're gonna raise the first flag. And if it's P, we're gonna raise the partial flag. So imagine we have, let's say, dash S, dash C, and dash P, right? So originally option, which is, an unsigned integer, looks like this. We have multiple zeros. And we don't care about the rest, only the first 8 bits matter. And basically dash S will make the function go through this case, and it's gonna OR the option with sorted. Sorted looks like this. When we bitwise OR the sorted, which is this constant, with the option, then what's going to happen is the third bit becomes 1. Let's say dash C, which is going to be another constant. Let me use the red color again. Dash C is or the case, basically. Dash C represent case. So the case basically is another constant, which looks like this. And when you bitwise OR this with the option again, then the other bit becomes 1. So now this becomes 1. So now we have these two as 1, the rest are all 0. This is my option variable. The option is the variable that we're going to return from this function. And when I bitwise OR it with, what's the next one? P partial. So the partial looks like this: 1 0 0 0 0 0 0 0. That's the constant partial. When you do this, then we're gonna basically change this 0 to 1, right? Pay attention to all the other bits, because the other bits are 0. They're not going to affect the other bits of your option, because ORing with 0 is a neutral operation, but ORing with 1 will make it 1, right? And that's basically what your option is at the end, right? Let me clear all the drawings and go forward. If you don't see any of these characters and you see a different character, then it's going to go to default and it's going to raise an error with error code equal to 3. Otherwise, it's going to return the option at the very end. So you can use this for any C program that has command arguments. Not any, but like most of them. Basically, it's a very flexible function that allows you to, input multiple flags. All you need to do is change these flags to any flag that you want for your own program. This is just a good template for a set flag function in C for handling all the flags in a program where flags are passed as a command argument. So after calling the flag, the set flag function, the flags are set, and we are ready to basically use them in the program. The first flag I'm going to use is the reversed and sorted flag. Here, I will say, if you're using reversed flag and sorted flag at the same time, that doesn't make sense. So raise an error 4, because you cannot print the output with both sorted and reversed option, because they contradict each other. Sorted wants to sort them alphabetically, reverse wants to reverse the list of lines. They both cannot happen at the same time. So we're going to raise an error and ask the user to either remove the sorted flag or remove the reverse flag. And after that, I'm going to call another function read lines, which is responsible for handling the input stream. The read lines is also defined here. As you see, right before the read lines, I have created a array of strings, line pointer, with the capacity of max lines, where max lines is defined to be 1,000. And in the header file, I have declared the line pointer as an external variable because it is defined externally outside of all the functions. So I can refer to this anywhere in the program because I have defined it externally and I have declared it externally as well. So in the read lines, I'm going to read all the lines from input and store them in this nice data structure. The reason I say it's a nice data structure is because it's kind of like a ragged 2D array. It allows you to store every line in an array of char stars, and each line is going to be stored in the heap. And for each line, you only reserve or allocate the required number of bytes. You're not wasting any space. So it's a very efficient data structures for storing an array of lines. And in this function, all I need to do is I first create a placeholder for a single line. The assumption is the length of each line doesn't exceed 1,000. Max len is a constant that is, defined to be 1,000. And then in this while loop, I use fgetS, my favorite function, to get a line, pass the line max len and std in. If this doesn't get any other line, or if there's no other line, fgetS returns null, and null means false. So we're going to get out of the while loop and we're going to return the number of lines. Number of lines is initialized to 0. So if the user doesn't enter anything, we're going to return 0. Then I have the following. First, I'm going to get the length of the line. Then I'm going to basically allocate enough number of bytes for the line because I'm going to copy the line into the heap. So I need to allocate enough bytes in the heap for the line. The length plus 1 basically means I need to have this many bytes plus 1. The plus 1 is because there will be always a backslash 0 at the end. So after this, what I'm going to have is this if statement. After you allocate, if the malloc returns null, that means we don't have enough space in the heap. Or if the number of lines exceeds the maximum possible number of lines you can have, which is 1,000, then you can return -1. -1 returns is returned when you have an error in your read lines. If there's no error, then your number is not going to be negative. It's going to be either 0 or positive. And then if the if a statement is not executed, we're going to go to the else part, and we are going to copy the line that we received from input using fgetS into the location that we have allocated in the heap, and we're going to store this location in the array of line pointers at index n lines, and we're going to increase the n lines by 1. This if statement basically drops the new line at the end of the line, because when you call fgetS, most likely you're going to have a new line at the end of the line. So that's why I basically said, if you see a new line at the end, drop it by setting it equal to 0. And that's basically it. That's all I need to do for the read lines function. After this, after my read lines is implemented and works by reading all the lines and storing it in line PTR array, then I have to begin the operation. First, I will say, is the option contains a sorted flag? If so, by the way, you may wonder, why does this if has only one AND? this is a bitwise AND, not a regular double AND, logical AND that you are used to in your other programs. The single AND basically means we are bitwising, bitwise ANDing the bits of sorted with the option. So ideally, you don't know, or of course, you don't know what the options are, because every time you run a program, the user may enter a different set of command and arguments. But I'm going to assume that we have unknown first 8 bits for the flag. When I bitwise AND this with sorted, which is 0, 0, 1, 0, 0, 0, 0, 0, then the output is going to be x and 0, which is 0, because as you may know, when you do logical AND, when you do bitwise AND, or when you do the AND of any bit with 0, the output will be 0, because false and true is false, false and false is false too. So this would be 0, 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 this would be 0. And then x and 1 would be x. This is called bit masking, because basically eliminating all of these bits that I don't care about from consideration. I only consider x. If x is 1, then this bitwise AND gives me non-zero values. And if it is 0, it gives me a 0 value. So when I say option and sorted within an if statement, this is what I mean. I mean, is option and sorted equals a non-zero value? If it's non-zero, in C, non-zero means true. So that means the sorted flag has been raised. If it is 0, that means the sorted flag is not raised. And what I'm going to do here is, if the option and sorted is non-zero, which means the sorted flag is raised, call the quick sort on the line pointer 0 and number of line -1. Basically, quick sort is going to sort the array of lines. How does it work? I have created my own quick sort, because the original quick sort requires the quick sort in stdlib requires a function pointer to the function that compares them, and it is defined for a general case. I didn't want it to confuse you here, so we're going to keep it simple. This is the quick sort. It uses a subroutine swap, and subroutine swap is defined generic case. It gets an array of void stars and 2 integers, and it swaps the element I and j of this array. And then the quick sort gets an array of strings or char stars, a left index, a right index. The reason I pass left and right is because every time I have to pass a subarray, so that I can call the quick sort recursively. As you see, I've called it twice recursively. And for those of you who know what quick sort is, you know that there's a pivot involved always. The pivot is at index left plus right minus left over 2, which is basically the middle index. This is basically the same as left plus right over 2, but this is better than saying left plus right over 2, because when you say left plus right minus left over 2, you're eliminating any chance of overflow in integers. And we're going to swap the middle element, which is my pivot, with the leftmost element. Then I will create a last integer set it equal to left. And this last will always represent a last element in the left subarray that is going to have values less than pivot. And everything in the right subarray will have values that are greater than pivot. And in this for loop, I will make sure that every element less than pivot goes to the left of the pivot, and every element in the right greater than pivot goes to the right of pivot. And at the end, I will swap left and last. Left was the location of pivot, and last is the final location of pivot. And then after I do this swap, I will call the quicksort twice. You can check out my other videos for the different the explanation of this quicksort operation. I don't want to go over this again because this video becomes very long. So I'm gonna get back to the main and tell you what should I do next. After calling quicksort in the case of a sorted flag, I gotta do this. I'm gonna have a for loop. This initial string is a placeholder for the initial string at the beginning of every line, which may include the line number. Then in this for loop, I go over all the lines and I will say if option and numbered is non-zero, that means if I have a numbered flag, then set initial to this. Basically, initial basically represents a string made of the index of the line, followed by dot, followed by a space. And I'm gonna set this equal to I+1. That was a mistake. I'm gonna fix that. Because line pointer index is I should add it by 1 because index starts from 0, but generally speaking, when you number a line, you're going to begin with 1. So I got to add it by 1. And sprintf basically converts this integer using this placeholder to a string and stores it in initial. So that's a great function to use. It's in the string.h. You can use it for all sorts of string formatting. That's a great tool to use. It's basically similar to printf. The only difference is it gets a string at the beginning, a choice at the beginning. And instead of printing the string on the standard output, it prints it on this string, or it places it in this string. So because you know printf is extremely easy to use, you can use it anytime you want. After this is printf, I'm going to have this search operation, strstr with option. As you may remember, or you may not know this, strstr is a function in a string.h library that looks for a needle in a haystack. The haystack is the first parameter, the needle in the second parameter. strstr with option is my own function that I defined. I'm going to show you the definition that gets 3 parameters: the haystack, the needle, and an option. And it looks for this needle in the haystack with these options. The options can be case sensitivity, -c basically case, or it can be match, which basically means should I match a whole word or fully match a whole word, or I don't need to fully match a whole word. So the option is passed because of the case sensitivity and whether or not you want to fully match the pattern with a whole word. strstr with option is defined in another file, util.c. In this case, you can see strstr with option, with haystack, needle, and option. What I'm going to do is I'm going to first check whether the case flag is raised. If that's the case, I'm going to lower the case of the haystack and needle. Before doing that, I have to duplicate them because I don't want to lose the original copy of haystack and needle. So before lowering the cases, I gotta get a copy of them. This copy will be stored in the heap, so it's gonna be a great way of preserving the original copy of haystack and needle, because I don't want to change the cases of the original copies of standard input lines. ToLower is another function, another subroutine that I defined. It's basically go over every single character and lower the case of the character in the array of characters input. And that's it. After I lower the case, I'm gonna check whether or not the matched flag is raised. If that's the case, then I call another subroutine strstr fully matched, which is a version of strstr that only fully matches a needle in the haystack. It doesn't matches a needle in haystack if needle is part of a word, not the whole word inside the haystack. And otherwise, it's going to call the regular strstr function. As I said, this exists in string.h, so I didn't create it myself. And that's it, it returns that. This strstr returns a pointer to the beginning of, to the first occurrence of needle in the haystack. And if the option is not case, I'm going to check if the option is matched or not. If it's the case, then I call this subroutine. Otherwise, I call the strstr with haystack and needle. The strstr fully matched is another subroutine, as I mentioned. I use it multiple times. I call it static because I don't want to use it anywhere outside of this file. And what it does is basically gets a haystack and a needle. It pads the needle with some spaces before and after it. And then it uses strcmp to check whether the needle exists in the haystack. This first if is to see if the needle matches the whole haystack. That means haystack equals needle. If that's the case, we found the needle in the haystack. We're going to return the reference to the needle's occurrence, which is going to be the haystack. Otherwise, we're going to check whether needle is at the beginning of haystack by doing this. Using strncmp. strncmp gets two char stars, and the n means it gets the third parameter. The third parameter is an index. That index is basically tell us how many characters should we compare the two string with. So if n is, let's say, 5, we're going to compare the first 5 characters of haystack and the second operator, or second operand, I should say, or the second parameter. So with this, I'm going to check whether the needle is at the beginning of the haystack. If that's the case, I will return the haystack, which is the reference to the first occurrence of needle in the haystack. And otherwise, I'm going to do this if a statement, which basically checks whether the needle is at the middle of the haystack. If that's the case, I will, again, return the pointer to the first occurrence of the needle. And in this last part, I check whether the needle is at the end of the haystack. If that's the case, I will return the pointer to it. And finally, I will return null, because if I cannot find it at the beginning, at the middle, at the end, or if the needle is not equal to the haystack, you cannot find it anywhere else. So I return null. I know this is not so easy to do. It's quite complicated, but I just did it for you because I didn't want it to give you a very hard time. So what I'm going to do is I'm going to go forward with the rest of main function. We have more options. For example, if option and accept is raised, that means if the accept flag is raised, and the first occurrence, which is the return value of this function, is not null. That means if we find the pattern in the current line and the accept is raised, do not print it. So this would be 1, this would be 1, and they're not equal, so don't print it. But if the accept flag is not raised, so this is false or 0, but we find the pattern in the line, which means the first occurrence is not null, so they wouldn't be equal, so let's print the line. In the other situation, if this is null, that means you cannot find it. You cannot find pattern in the current line. And accept is raised, this would be 1, this would be 0. Because they're not equal, we're going to still print the line. And if this is null, which means this condition is 0, and the except flag is not raised, so this would be 0, then they're not equal, they're equal, both of them are 0, so don't print the line. So this is basically assures that if the except flag is in a way that you must print the line, print it. How do you print it? We do printf, %s, the first %s prints the initial, which is either empty string, or if it's number, it's going to be a number at the beginning of the line, followed by the string, and that's it. So this is the whole program with all the details. Now it's time to test it. Before I test it, what I'm going to do is I'm going to show you some example of input and outputs. Imagine the input stream looks like this. I'm very interested in computer science, new line. This is a test statement, new line. I'm in, new line, in and out, has great burgers. In fact, new line, last sentence, in, new line. There's no new line, this is Control D. And then I have placed a bunch of examples here. Let's say the program is find, so that the /find is the name of the program, because I assume the find is in the current directory, so I use /. And I'm looking for the pattern in, so it's going to print every line that contains the keyword in. I'm very interested in computer science. This is printed. I'm in. This is printed. In and out has great burgers. In fact, printed gets printed because of this. But for example, this is not going to be printed, or this is not going to be printed because they don't have the keyword in it. If I say FMN, F stands for first occurrence, M is fully matched and is numbered. So as you see, we see the numbers. The M means you're going to fully match the word, and N means N means the number. F means we're gonna have the first. We're gonna print the location of the first occurrence of the pattern. So in this sentence, I'm very interested in computer science. There are two occurrences of in. One is this, one is this. But because we're gonna fully match it, the location of the leftmost occurrence of the word in is not going to be here. It's going to be here. So this is the location of the first occurrence, which is 20. That means if you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The letter I is at index 20, and therefore it prints 20. In the sentence I'm in, it's much easier because there's only one occurrence, and it's going to be at index 4. 0, 1, 2, 3, 4. So the I is at index 4. And then the last one is in and out burger, has great burgers. In fact, the occurrence that the first occurrence of in would be this. So we're going to return, we're going to print the index of that, which is 27. If there was no F, I'm sorry, if there was no M, which means it doesn't ask you for the whole word match, then you could say the index is going to be 0 because in the in and out has the keyword in, right? And by default, we are case insensitive. No, sorry, by default, we are case sensitive. So let's put it this way. If instead of M, I have C, if you replace M by C, then you should see 0 here because there's no fully matched and there's a case insensitivity. So in would be considered as one of the occurrences of the word in. And the first occurrence would be at index 0. The next one is -SR. That means I'm going to both sort and reverse. You're going to get an error message saying you cannot use S and R at the same time. R and X. means reverse the order and prints the ones that do not have the word in. So it's going to reverse the order. First, it's going to print this, and then it's going to print this. The rest do have the word in them, so we don't print them because of the letter X in the flags. And then PCM means let's have partial print of every sentence. C means case insensitivity, and M means fully match. So this is what you're going to see. As you see, because let's say this sentence was very long, we're going to have two ellipses, one at the beginning, one at the end, just to condense the sentence. I've already posted some explanations about how partially print works. You're going to read this carefully to understand all the details of it. And that's pretty much it. So it's time to run it. I'm going to run this incomplete starter code for you so you can see it. We're going to go to this party. I'm going to do make first. By the way, the make looks like this. I forgot to show you the make. The make file is basically only takes the find of util.c into consideration. And after you compile it successfully, then you can run it this way. Let's say I'm going to say dash n, the word is apple, and then I will say I love apples, apples and oranges are great for dessert, and apple pie is my favorite dessert. And then let's put words, let's say apples at the end, and then I'm going to put Control D, and that's going to show me all the matches. One is I love apple, and as you see, it's numbered because of -n. So 1 is printed, 3 is printed. This is not printed because by default it's case sensitive. And this is printed because by default it doesn't need to match the whole word, so apples will be printed. If I run it this way, let's say dash and dash, let's say dash cn to make it case insensitive, and then I just copy the same input, then I will see number 2 as well, because that's how it should be. If I, let's say, add an X here, and I just do the same thing. Sorry, apple and oranges are great for dessert. Let's add these 2 as well. And then Control D, it shouldn't print anything because all the 3 have apples in them. So the X means include them all. So it doesn't need to print anything. Let me show you one more example. Let's see, we're going to have S. We're going to have M. M means match fully. S means sort them alphabetically. When I, let's say, grab these and print them here. So I'm going to pass these 4 lines. I love apples. Apples and oranges are my great desserts and my favorite dessert, and apples. When I press Control D, it's going to only print one of them, which is apple pie is my favorite. The rest is not going to be printed because of the letter M. M means fully matched, and this is not going to be printed. If I add, let's say, a C flag as well, and sorry, and copy the same input, which are these. No, yeah, these are the ones. And then Control D. It shows me this again because it's gonna fully match. So again, it doesn't match the apples. But if I remove the M and only have C and S, you can see there are many ways of running it. That's why I keep running it with different values. So then this can show you this sorted as well. Let me make sure everything is correct. Yeah. All right, so when I press Ctrl D twice, as you see, it prints this because it's case sensitive, so it understands it. It prints this, it prints this, it prints this. And as you may have noticed, this is sorted alphabetically. First capital letters, A comes before I, and then the lowercase letters, apple comes before apples because it's alphabetically lower. So it works, the sort works as well. So that's pretty much it. I would say it would be a great practice if you finish doing all the functionalities, all the flags yourself. All right. Have a good day. Bye.